In the last 2 decades, there has been a growing awareness of the possible adverse effects in humans and wildlife from exposure to chemicals that can interfere with the endocrine system. A chemical is defined as having endocrine disrupting properties if 3 criteria are all met. The chemical shows an adverse effect. The chemical has an endocrine mode of action, meaning that it alters the function of the endocrine system, and a connection between the two, effects and endocrine mode of action, is demonstrated. A technical guidance for the identification of endocrine disruptors was published in 2018 thanks to the joint effort of ECA and EFSA. In this guidance, the use of in silico methods is included in the first phase of the weight of evidence assessment workflow, as these methods can provide evidence for the presence of an endocrine mode of action. But what are the issues of employing in silico approaches in this context? Well, the issues are that the endocrine system is a complex system which involves multiple glands, multiple mode of action, and multiple AUP. This means that multiple models have to be employed, each of them able to address a specific part of the whole system. With this in mind, we design a prediction workflow with the aims to use the existing models to combine the predictions of various models into an overall assessment and to address different applications. It is worthwhile highlighting that the aim of this workflow is not to generate a consensus prediction, but to use the existing information to generate an hypothesis on the endocrine mode of action. These are the elements of the workflow. First, the predictions are generated. Then, the results are normalized in order to be able to combine the predictions into an overall assessment. If you are interested in a screening application, you can use the results generated at this stage. For a more detailed assessment, an expert review is carried out on the positive and the equivocal results, and a detailed report is generated. Two of these steps, the normalization and the combination, can be automated, and we are in the process of implementing these 2 steps into an IT platform called NIME. Let's now see the first 3 steps of the workflow in more details. Disruption of the endocrine system can occur in various ways through the interaction of a chemical with either a nuclear receptor or a protein of the endocrine system. The available in silico approaches able to model and predict interactions with a specific nuclear receptors or a specific proteins are statistical-based QSAR models, either classification models and regression models, rule-based QSAR models, structural alert and decision tree, molecular modeling or docking methods, able to study the interaction between a small molecule and a macromolecule, such as a receptor or a protein, and ToxCast pathway models, available through the EPA CompuTox dashboard and based on in vitro data. In total, we use 113 models, and we are evaluating some others to be added. The models are grouped according to the modalities estrogen, androgen, thyroid, and steroidogenesis, being the ones of most concern. We also consider another modality, grouping under it models addressing receptors and proteins related to the endocrine system other than the EATS modalities. As each tool, and sometimes each model, express the prediction with its own vocabulary, it is necessary to normalize the results in order to be able to combine them. These are just examples of the normalization tables that are employed in the workflow. We consider three values of the prediction: positive, negative, and equivocal, and three values for the assessment of the applicability domain: inside the applicability domain, outside the applicability domain, and borderline. Once normalized, the predictions of the various models are combined, taking into consideration the accuracy of the models in terms of sensitivity of the model, so the ability of the model of predicting the positive, the nature of the model itself. As an example, as the rule-based models are known to result in too many false positives, they are mainly used to confirm a positive prediction. Then we consider the validity of the prediction itself using the predictions that are within the applicability domain of the model. And we also calculate what we define as the robustness of the prediction, that encode the information of how many of the available models are used for the assessment. The workflow has been applied to 10 case studies. 4 molecules were extracted from the ECA endocrine disruptor assessment list. 2 of them were assessed as non-ED and 2 were assessed as ED. And additional 6 molecules were extracted from a database developed from the FDA. And again, 3 were known or assessed as not active towards a receptor, while 3 were known as active towards a specific receptor. Now, we have to say that there are some doubts related to molecule number 7 that was archived in this database as not active towards the androgen receptor, but in reality we found some other literature evidences suggested that this molecule is in effect active at least towards the estrogen receptor. Now let's see in more details the results for the first 2 molecules. Let's see the results for molecule number 1. This molecule has been assessed as a non-endocrine disruptor, and the results of the prediction that you can see here are mainly negative. Only for the estrogen modality we see some positive results, but of these only one is statistical and it is saying an equivocal result, so not definitely positive. And the other 2 are rule-based models that we already mentioned are usually very rich in false positive. So even with these 3 equivocal and positive predictions, there is not a strong evidence that this molecule is active towards the estrogen receptor, because we have at least 20 statistical based models that are predicting this activity as negative. The second molecule that is known to be an endocrine disruptor, it starts to give us much more positive evidences. And among all the positive results, the ones that are more probable is the estrogen receptor, the activity towards the estrogen receptor, because we have a higher number of models that are positive in that case. And once you get to this point of having positive predictions, you can also dig into more details related to the mode of action, generating tables like this one, where you also can distinguish between the different mode of action. And here we have as an example that for the estrogen receptor, for which we have a higher probability of a positive results, having at least 12 models suggesting a positive results. And the mode of action that is suggested is binding, so not able to distinguish between agonist or antagonism, but just suggesting that a binding with the estrogen receptor is possible. If we apply the workflow to the 10 molecules that we have seen before, we see that they are all well predicted except for molecule number 7, for which we know that we have doubts about the experimental assessment that we found in the database, because there are some evidences in literature that indicate a activity towards the estrogen receptor of this molecule. But all the others, they has been predicted as activating somehow with different modalities the endocrine system. So in conclusion, our in silico screening protocol is able to combine the results of 113 models and to predict the potential of a chemical to interfere with the endocrine system, giving an hypothesis on the active modality and the active mode of action. Out of the 10 case studies, 9 were correctly predicted as activating or not activating the endocrine system, and 1 resulted as a false positive, but with some controversial evidences suggesting that it might be actually positive in sense of interfering with the endocrine system. The protocol will be implemented in NIME, the 2 steps that can be automated to avoid possible transcription errors. So I thank you all for the attention, and please contact us if you're interested in having your compounds screened at info@docsnavigation.com, or just contact me directly at elena@docsnavigation.com if you have comments or questions related to the presentation. Thanks again.